So in this video, I want to talk about Lewis structures. And how to draw them. And so the purpose of Lewis dot structures are to represent a molecule, and then they help visualize where bonding electrons are. So visualize where bonding electrons are. Electrons E minus. And then it also allows you to visualize where lone pairs are. And what lone pairs are unbound electrons. So electrons essentially not being used for a covalent bond. And then finally, most importantly, it's used to determine the formal charge. And so let's do some examples and practice. So in general, what you want to have is, let's talk about a couple different elements, the most common elements you'll see. So hydrogen, carbon, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And so let's make a little chart. And so here is the preferred number of bonds, and then here is preferred number of lone pairs, LP. And so hydrogen, this is a generalization, it's not always true, but for neutral, uncharged atoms, keynote there, uncharged. And so a generalization is hydrogen will like to have one bond and no lone pairs. Carbon likes to have 4 bonds and no lone pairs. Nitrogen likes to have 3 bonds and 1 lone pair. And oxygen likes to have 2 bonds and 2 lone pairs. And fluorine, chlorine, bromine, iodine, they all like to have 1 bond and 3 lone pairs. And so let's see how this works out when drawing Lewis structures. So there's a formula. And so the formula says that formal charge equals the number of valence electrons minus the number of lone pair, LP, lone pair, electrons, and then minus 1/2 of the number of bonding electrons. And so the number of valence electrons can be determined by the columns. So here is a periodic table. A crudely drawn periodic table. We won't worry about this over here. So 1, 2, 3, 4, 5, 6, 7. And so the number of valence electrons, so this whole column has 1, this has 2, this has 3, 4, 5, 6, 7, and 8. So that's how you determine the number of valence electrons. And so that's a periodic table. So here, for example, bromine, carbon, nitrogen, oxygen, fluorine, and helium up here, hydrogen, and then beryllium. So something like that. And so this whole column has, for example, this column right here has 3 valence electrons. And so now let's draw a structure and draw a Lewis structure. So an example, let's do this. Actually, we'll do this. And so how do you determine the formal charge on nitrogen? Well, it has 2. I want to use a different color. So it has 2 lone pairs. So, I mean, let's use 2 non-bonding electrons, and then as you can see in this bond being used right there, it has, so it's 3 bonds, so 1/2 of 3, because 3 is a number of bonding, 6, sorry, 1/2 of 6, because you have 6 electrons in that triple bond. Each one of those lines represent 2, and so 1/2 of 6 equals 3. And so we also know that nitrogen, being in that group 5, has 5 valence electrons. And so the formula is number of valence electrons minus number of lone pair electrons minus 1/2 of the bonding electrons. And to tell you the truth, you could just, instead of doing this whole formula, you could just count how many bonds it has. And so this would be 5 minus 2 minus 3 equals 0. So it's a neutral formal charge. And so let's try another example. We'll use this. Once again, you know that the nitrogen we just did has a formal charge of 0, but this carbon looks a little weird, so let's look at that. It has 2 non-bonding or lone pair electrons, 3 bonds, and 4 valence electrons. So the 4 valence electrons minus the 2 bonding, non-bonding, the lone pairs electrons, minus the 3 electrons contributing to the bond. So we'll just do 1/2 of 6 right there. That gives you -1. And so if this molecule is written correctly, there should be a negative on the carbon. And so one thing to note is, if you're just starting with drawing the Lewis structures, what you can do is you could add up the valence electrons. So let's say you have a C2H2. So you know carbon has 4 valence electrons and hydrogen has 2, right? So if you want to draw out the Lewis structure, you add it all together. So 4 times 2, because you have 2 carbons, plus 2 times 1, because you have 1 valence electron in hydrogen. So you have a total of 10 electrons that must be used when drawing the Lewis structure. And so 10 electrons equals 5 bonds. So you could have something like this when drawing out the Lewis structure. And as you can see, 1, 2, 3, 4, 5, and so it all adds up. Because remember, each bond represents 2 electrons. And so let's do one more. Let's try a water molecule. So we'll start from the beginning, H2O. So how would you draw the Lewis structure? Well, you know oxygen has 6 valence electrons, Oxygen has 6 valence electrons, hydrogen has 2, and so you add it up, total would get you 8 electrons, and so you know you have 8 electrons to use when drawing the Lewis structure. And so if you draw an oxygen here, and then so that uses 8, because 2 here, 2 here, and then 2 lone pairs, which is 4 electrons. And so let's calculate the formal charge for oxygen. So it has 4 number of lone pairs, so 4 electrons for the lone pair, and then 2 bonding with the hydrogen, so 1/2 of 4. And then so you do valence electrons, 6 valence minus 4 non-bonding, so those are the lone pairs, minus 1/2 of 4, 2, and then that gives you 0 as the formal charge.